All right, so on 32, so if you have something like this, then what you're going to do is you're going to cube the first term. Now, if it's it'll go plus 3a squared b plus 3ab squared, and then plus b to the third. Now, if it's a subtraction problem, then the last term and the second term are going to be negative. Okay? So if it looks something like here in blue, and it is a minus b to the third, it's still going to be a to the third, but it's going to be minus 3a squared b plus 3a b squared, and then it'll be it should be a minus b to the third. So like in this case, where it's x minus 4, it's going to fit that form. So I'm going to take x to the third. Then essentially what I would do is I would go minus, or really what you're doing is you're just going to take 3 times x squared times the negative 4, because what that's going to do is it's going to make it negative 12x squared. Like, there's where your negative comes from. Okay, it's basically like if you just take the whole thing. Does that make sense? So I have x to the third minus 12x squared. Do the same thing, but it's going to be like 3 times x times negative 4 squared. So negative 4 squared is 16. 16 times 3 is 48. So it's going to be plus 48x, and then minus 4 to the third. So 4 to the third is 64. Because then I'm doing negative 4 to the third power. That's going to be your shortcut instead of, like, you can multiply it out. Like, realistically, you could go and do x minus 4, x minus 4, and then x minus 4. Like, you could multiply the first two out and FOIL or double distribute, whatever, and then re-multiply that trinomial with the binomial. But this will, that will shorten your workload a lot more there. So on 12, it's a union. So you're not going to rewrite. So basically everything that you have in each one that is going to be in your set. So, but you're just not going to rewrite. So like if I have A, so I have an A, I have a C here and there, but I'm just going to write it one time. I have a D in each one, E, F, and then H. Same set on 11, but it's the ones that match or are in each set, so it's just going to be C and then D. So,
do we need to have the brackets in the answer? Or?
Yes. Okay. It should look something like that. Okay. All right, 18. So I have inside, I have negative 6x to the second, y to the sixth, all to the 0 power, times 3xy squared times negative 4x squared. So is it the 0 that's throwing you off? Yeah. Okay. 0 to anything, 0 a power of 0 is what? 1. So what is all of this going to turn into? Just a single, right? 1. Then it just becomes 3 times negative 4. So negative 12. X times x squared, so it's going to be x to the third. And then the only y that I have is y squared, so there you go. That's the move. Alright, so on 20, you can really do this a couple different ways. Alright, the way that I would do it is one way, the way somebody else would do it is maybe another. What I would do is I would put it together and make it into one just because it's easier to simplify. That's more for my technique. And so like I would go ahead and multiply, since they're both underneath the radical, I can multiply 50 and 6 together, right? So I can have the square root of 300. I think that's a lot easier to simplify out, because what is the highest perfect square that I can factor out of 300? 100, right? So then I can just go square root of 100 times the square root of 3 and have 10 square root of 3 and call it good. Now, what you may see, I'm assuming since you asked the question, that you took the square root of 50 and you had the square root of 6 and you factored out the square root of 50, right? Okay, which is fine, because whenever you did that, you had square root of 25 times the square root of 2, and then you still had this square root of 6 kind of hanging out there. So I had 5, and then I had the square root of 2. Now, even here at this point, there's still 2 approaches that I could do. Okay, I could multiply the 12 or the 2 and the 6 and get a 12, right? And then factor out that 12 and have a 4 and a 3, right? So that's one option. Or I could even break up, like I'll have some students that will go like this and break up that 6. Like that's even an option. Okay, so now you have 2 square root of 2s, so what's that going to do? What's square root of 2 times square root of 2 going to be? 2, right? So I'm right back to, because this is just 2, 5 times 2 times the square root of 3 is still 10 times the square root of 3. Okay? So we got the same answer. It's really up to you as far as how you see it and what you do. Me, what I'm going to do, as long as that number's not really, really huge, like 300 is not that bad of a number to deal with. Now, if it's like in the thousands or 2000s or whatever, then yeah, I'm going to probably break some things up. But if it's 300, that's probably going to be something I can work with. And so I would probably go more the red and the blue route than the green route. Or cannot have a radical in the denominator. So in doing this, I need to multiply the top and the bottom by the conjugate of the bottom, or of the denominator. So in doing that, I'm going to multiply the top and the bottom by the square root of 2 minus the square root of 6. Now, remember, whenever I multiply by a conjugate, I'm just going to worry about the bottom right now, and then I'll come back to the top in just a second. So remember, whenever I multiply with a conjugate, I only have to multiply the first 2 terms and then the last 2 terms, and I kind of go from there, right? So what's the square root of 2 times the square root of 2 going to be? 2. So I'm going to have 2, and then it's going to be all automatically a minus. Square root of 6 times the square root of 6 is 6. Okay, so what's the bottom actually going to be? -4. Now, what I do here is going to be probably a little bit different. I'm not going to, normally I would distribute that 4 to everything in, like everything in that other numerator, right? But in this case, because I have a 4 right here, and I have a 4 right here, I'm really just going to leave it, and I'm going to have 4 times the square root of 2 plus minus the square root of 6. So what's going to happen to those 4's? They're going to cancel, and realistically, what am I left with? A -1 on the bottom. So my final answer is just going to be negative times square root of 2 minus square root of 6, which is really just negative square root of 2 plus the square root of 6. Now, even if, and I'm going to kind of put my little disclaimer here in this little box, even if you multiplied the 4 and went 4 times the square root of 2 minus 4 times the square root of 6. Since everything was divisible by that 4, you can just divide each one out. Okay? Or you could have written it, you know, I'll even have some students that would have done this and written -4 on each one and had -4 times the square root of 6 over -4, and it's still going to work out because the 4's will cancel here, 2 negatives make a positive, and they cancel there, and I'm still going to get the same answer. Okay. A lot of with the radicals, to be perfectly honest with you, there's a lot of different ways that you can kind of simplify. There are certain things that you have to do, like we had to multiply by the conjugate. But once we simplify it out, it's really up to you. You know, kind of when we get past that little line right there and everything on the right side, there's kind of options. Okay, and you have those options that you can go with. Now, on 23, again, this is one of those that we can do it multiple different ways. The way that I would do it is possibly different than the way that others would do it. Since they're both underneath the cube root, I can essentially rewrite this as the cube root of 32 over 2. What's 32 over 2? 16. Cube root of 16 is going to be a heck of a lot easier. Now we just simplify it, right? So what is a perfect cube? Not squared, so don't put 4. Okay, it's going to be 8 and 2, right? So I'm going to break it up as the cube root of 8 times the cube root of 2. Cube root of 8 is 2, so 2 times the cube root of 2. Now, I will tell you, I had a student yesterday ask me, well, then they wanted to rationalize it. Okay, they just wanted to rationalize the denominator. That's completely fine. Just make sure that it's a perfect cube and not a square. Okay, I think they wanted to go like 2 and 2, and so that still made it the cube root of 4. Nothing's going to cancel. Okay, so they had to multiply it by another 2 again. Okay, so making sure, but if you can, making sure that you multiply the denominator and the numerator by whatever's going to make it a perfect cube, fourth root, whatever you have as far as your root or your index, we've got to make sure that that's going to be a perfect number underneath the radical. All right, 25, again, you want to, first things first is, if I can't combine anything inside the radical, so I have x to the 1/3 and I have y to the -1/2. Since you have a negative, if you want, you can put that y to the -1/2 on the bottom side if you want. It's completely up to you. Bless you. for me, what I'm going to do is I'm just going to go ahead and distribute that 6 into everything. I'm going to multiply it. Okay, remember, it's a power of a power, or really a power of a product. Okay, so that 6 has to get multiplied with every exponent in there. So what's 6 times 1/3? Okay, what is 6/3? 2. Then it's y to the negative, what's 1/2 times 6? 3. So here's what I'm looking at, but now what do I need to do with that? What do I need to do with that negative exponent? Put it on the bottom side. So x squared equals y to the 3rd. Alright, with 40, 2x squared plus 10xy plus 5xy plus 25y squared. Again, you have options. You can combine, but it's already put out there, like we can combine everything and go from there. But if it's already separated out for us, go ahead and do that. I would go ahead and do this by grouping. Okay? So even though it's like they already did a step for us right here, so let's go ahead and just do it by grouping. And what can we factor out of the first two terms? 2x. So if I factor out a 2x, I'm left with x plus 5y. Now, remember, if I'm doing it by grouping, then I need to have an x plus 5y here. What do I need to divide each? If I divide each of those by something, what's going to get me the x plus 5y? Like, what's 5xy divided by the x? Plus 5y, right? So the 2 that are in the parentheses become 1. And then the 2 parts on the outside are its own.